Electronegativity, the final periodic trend in my series. So, what is electronegativity? Well, a textbook's going to give you a definition like the ability of an element to attract electrons in a chemical bond. And so, what does that really mean, right? So, if we look at two atoms from the same element and they are in a chemical bond, a covalent bond, they're going to be sharing the electrons in an equal manner, right? An equal manner. So if I have like a fluorine and another fluorine, and they're bonded to each other, well, they both have the same attraction to electrons because they're the same element, right? But what if I have two different atoms, right? What if I have a hydrogen and a fluorine? Well, now we have two very different atoms, right? Hydrogen being on the top left of the periodic table and fluorine being right over here. They have different ionization energies, different electron affinities, and then, we can look at other things, but we know that they have different attractions to electrons. And so electronegativity is a scale. It's not like some intrinsic value that you can determine experimentally, like ionization energy or electron affinity. It's a scale, like a ranking of the elements that shows how strongly they attract the electrons in a bond. And so fluorine is actually the most electronegative element, and its electronegativity, according to the Pauling scale, is a 4.0. So you can think about it like a GPA, right? Most schools have a 4.0 as the maximum GPA you can get. That's the same with electronegativity. So fluorine is the 4.0. It's the most electronegative element. And hydrogen is a lower value. It's like 2.1. And so the idea is, based on having a difference in electronegativities between these two elements, we can say that the high electronegative element is going to be kind of hoarding the electrons in that bond more strongly. And so that means that the electrons are going to spend more time on that side of the molecule, which is going to make the molecule polar because it's a polar covalent bond. We can talk more about polarity and bond types in another video, but the point is electronegativity helps us determine these things. So what is the periodic trend? Well, if we think about the first periodic trend that I did, which was atomic radius, I taught you guys over there that elements get larger as you go down. Of course, that makes sense. They're getting larger as you go down. But the reason is because we're adding new principal energy levels of electron shells, right? Each period that we go down. I also have a video on atomic orbitals and quantum numbers where I talk about these things, electron configurations. Check those out. So now as we go down, the electrons get larger. Now, as we go to the right, the atomic number gets larger as well, right? So, if we look at this, period 4, potassium is number 19. If we go all the way to the right, krypton is number 36. So the nuclei get larger. You have more protons and more electrons. But because we're staying in the same period, we're not adding a new valence shell of electrons. All we're doing is adding electrons to the outermost shell, right? And then we are adding protons to the nucleus, which is increasing the nuclear charge and attracting those electrons more and more tightly. So the elements actually get smaller as we go to the right. So in other words, as we go down and to the left, the atoms get larger and they get smaller. This is in general, right? They get smaller up and to the right. Now, if we look at ionization energy, it's inversely proportional to atomic radius in general. And so as the elements get smaller up and to the right, it takes more and more energy to remove an electron from that atom. And then electron affinity has a similar trend. It's going to increase up and to the right. In general, there's always exceptions, but it increases up and to the right as the atoms get smaller. And electronegativity is going to follow that same trend. So as the atoms get smaller up and to the right, the electronegativity is going to increase in general, okay? So the one thing that you're really not going to see is on most tables, you're not going to see electronegativities for the noble gases over here in group 8. You may see a value for like krypton and xenon because they can form chemical bonds. You'll see things, xenon difluoride. So you may see an electronegativity value there. But for the most part, you're usually not going to see electronegativity values for the noble gases because they really don't form bonds. So there's just no value to assign there, right? So yeah, guys, this is electronegativity. If these videos help you guys, please give a like, follow, share, save. Check me out over here to patronize me and continue making these videos for free. Thanks for watching, and I'll see you guys in the next one.